Hello again, everybody, and we're back with part 2 of verifying trig identities. So I have 5 more problems for you. All of them are going to be solved in slightly different ways, but we'll be using different identities to make one side equal the other side of these verification problems. So let's get started. At the top left, we have tangent of A equals secant A over cosecant A. So since tangent can be expressed as sine of A over cosine of A, I probably want to put secant and cosecant in terms of sine and cosine. So secant of A would be the same thing as saying 1 over the cosine of A. Cosecant A would be 1 over sine of A. I am dividing by a fraction, so I want to multiply by the reciprocal. So I would have 1 over cosine of A times sine of A over 1, and what do you know? Sine of A over cosine of A. Generally, the kind of fraction problems, you're just going to wind up flipping and multiplying, and they're not always very difficult. All right, let's move over to this one on the right. We have cosine theta equals sine theta times cotangent theta. So this is going to be the more difficult side, probably be easier to reduce down to cosine. So I want to write cotangent in terms of sine and cosine. So I have sine theta over 1 times cosine theta over sine theta. My sines will cancel out, and I'll just be left with cosine theta. So probably two of the easier ones we've had so far. They do progress in difficulty as this goes along. So if you need to write that down, go ahead and pause the video so you have a second. I'm going to go ahead and erase these and put up the next couple of problems for us. Alright, so now let's take a look at these two problems. We have secant of x minus tangent of x equals 1 minus sine of x over cosine over here on the left. So since this side is in sine and cosine, I want to take this side and put it in terms of sine and cosine as well. So secant can be written as 1 over cosine of x. Tangent can be written as sine of x over cosine of x. These fractions have a common denominator, so I can put them together. And we have verified the identity. All right. The next one will up the difficulty slightly. All right. So clearly the left side is going to be the more difficult of the two here. I have sine and cosine on bottom. The only thing really on top I can do is this tangent. I'm going to turn it into a quotient identity, use sine over cosine, and then kind of see where I can go from there. So that would be 1 plus sine of x over cosine of x over sine of x plus cosine of x. All right. Now you might think, well, where do I go from here? Well, I have this 1 here. I want to change this and write this as a fraction that I can add to sine plus cosine. Now, for fractions to be able to be added together, they have to have a common denominator. So I want to write 1 as a fraction with a denominator of cosine. And so the easiest way to do that is to write 1 as cosine over cosine. So if I write 1 as that, I can then add it to sine over cosine. So this would give me cosine of x plus sine of x over cosine of x over sine of x plus cosine of x, and that would technically be over 1. So now I'm dividing a fraction by a fraction, so I could flip and multiply by the reciprocal. So I would have cosine of x plus sine of x over cosine of x times 1 over sine of x plus cosine of x. Okay, and due to the commutative property of addition, these two things are exactly the same. Even though this is cosine plus sine and this is sine plus cosine, I could easily just rearrange them. And so since those are the same, they will cancel out. And all I'll have left would be 1 over cosine of x, which equals secant of x. So we have verified that identity as well. So we have one more problem for part 2. If you need a second to jot this down, go ahead and pause the video. I'm going to erase this so we can knock out the very last problem. Alright, so this is our last problem. We have secant of x times cosecant of x equals tangent of x plus cotangent of x. So the easiest thing to do here is probably just to go ahead and put both of these in terms of sine and cosine. So if I do that, on the left I'm going to have 1 over cosine of x times 1 over sine of x. If I did that over here, I would have sine of x over cosine of x plus cosine of x over sine of x. Alright, so here, what I'm going to wind up with on the left side is 1 over cosine x sine of x, because I would just multiply those together. Now, again, kind of like the last problem, in order to add these fractions together, they need to have a common denominator. So, the easiest way to achieve this is to multiply this side by cosine of x over cosine of x, and to multiply this side by sine of x over sine of x. And so if I do that, sine times sine is going to give me sine squared over sine x cosine x plus cosine times cosine, so cosine squared over sine x cosine x. And so now I could combine my fraction together. So I would get sine squared x plus cosine squared x over sine x cosine x. And most of you have probably already know this sine squared plus cosine squared, so that's simply going to equal 1. And so we now have a 1 on the denominator for both of these. This is cosine times sine. This is sine times cosine, which we could easily just rearrange since it's commutative property multiplication as cosine of x times sine of x. And we have verified the identity. So that's it for part 2. I'll have part 3 up shortly. These problems will probably be slightly more difficult than the ones we've currently worked. So if you found these difficult, you might want to go back over them before moving on to part 3. If you thought these were a walk in the park, fantastic. Hopefully you'll find part 3 just as easy. So thank you guys for watching, and we'll catch you next time.